All right, this is Jason Davis and Conor Fraser demonstrating the functionality of our ME305 term project. First thing we're going to do is going to restart our PuTTY window. All right, on boot up, we can just see what's initializing here. This is just helper information to see kind of what's happening before the program really gets started. First thing it wants us to do is manually level the platform. So rather than setting a nice home position, I'm going to go and just say this offset position is flat and level. Now notice that when I hit P, that actually returns our return our current position according to the IMU. And if we bring the panel back up to flat and level and hit P, we can now see right here that we are offset by certain amounts. So what I'm going to go ahead and do is fill a bigger. Okay, so I'm going to hit Z, which triggers the manual calibration sequence. So now that I have my panel nice and flat and level, I hit enter, and you can see that hitting P actually returns a nice correct orientation. The other options that we have in here, we already went through calibration and display. We're going to display our gain matrix to see what's been stored in a TXT file. Very nice. We could also disable the system as necessary. So one of the issues that we weren't able to work out is the actual touch panel calibration. So we won't be demonstrating that today. Unfortunately, we had code that kept crashing, and we just ran out of time to actually fix the bugs. We will be uploading source code, but however, we just want to mention up front that this functionality does not work on the panel. But we'll go ahead and demonstrate our best attempts at actually leveling the orientation of the panel with the motors. So Conor will go ahead and take over and talk about that.
So when it comes to balancing the panel, we use the strategy and approach from homeworks 2 and 3. We use a gain vector, we use a kinematic vector. That's our approach. It works to a certain extent. With the ability to change the K values, we can at least tune it with an easy user interface. But we'll see how it works. Let's hit B and give her a run here. And then let's start to move. And then bump up those gain values just so we can see some movement from the motors. You can see there's some slight movement, but right now we're just overcoming the friction from the motors, which of course is quite high on these small motors. See what we're getting at. You can see Jason is using the num keys to change our theta value. Now, for example, we could change our theta dot value, and you'll see maybe a more significant jump. Jason, if you want to hit the theta dot value and see, sure. That gives you a nice big jump. You see that there on the screen. I can definitely.
All right, it's okay. It's all right. So our PuTTY, we've been having issues with the microcontroller actually disconnecting from PuTTY. We'll go and just keep this rolling. We'll restart our session and we'll just pick up where we left off here.
Yeah.
So I'll restart in the PuTTY window here. We'll go and say this is flat and level. There we go. We're going to toggle the motor on. And there we go.
Continue balancing. Move up the gains. Oh, there we go. Now we're getting some movement.
Yeah, and unfortunately, the movement of the panel actually triggers disconnection of the microcontroller. So unfortunately, I think we've just been having issues with this hardware. We'll try one more time here, if it gives us the option to.
Regardless, our panel calibration was working due to some file changes around. It's no longer working. Our closed loop control is somewhat close. We have a lot of helper functions to help tune our gains. However, it seems not to be fully functional. But overall, the majority of this lab is completed. And the term project is, it's on its way to being completely finished, just not 100% of the way there.
Just more time.
Just more time.
And coffee. Thank you for watching this video. Thanks for bearing with us. Thanks for a good quarter.
Take care.